Welcome to the F5 Networks Advanced Web Application Firewall Demo and Exercise Series. In this exercise, we'll show how to use some advanced options when building security policies with BIG-IP Advanced WAF. Before watching this demo, we recommend you watch BIG-IP Advanced WAF Demo 8, which covers building security policies using automatic policy building. Exercise 14, which covers learning and enforcement. Exercise 17, which explains entity enforcement. And Exercise 34, which covers stabilizing security policies. This is an exercise which represents Demo 35 of the AWAF demo series, and it's intended for advanced level BIG-IP Advanced WAF users. For optimal viewing, we recommend using full screen mode. The environment for this demo contains 3 devices. A Windows workstation will be used for sending requests to build a new security policy. These requests will arrive at the F5 BIG-IP system, running Advanced WAF. The BIG-IP system sits in front of and protects the back-end web application. The BIG-IP system, using its full proxy architecture, examines every request before sending them to the back-end web servers. Through this process, BIG-IP Advanced WAF can build and update a web application security policy. We'll start by creating a BIG-IP Advanced WAF security policy for the DVWA web application. We'll give the policy a name. We'll select the comprehensive policy template, and we'll select the correct virtual server. We'll specify the web application language. And finally, we'll add a range of trusted IP addresses. By using trusted IP addresses, BIG-IP Advanced WAF will build the security policy much faster when we access and use the web application from one of the trusted IP addresses. We'll now open the Learning and Blocking Settings page. We use this page to configure nearly all aspects of security policy building. We'll expand the General Settings section. Each of the different sections on this page contains several violation types, and each violation type has 3 checkbox options. The Learn checkbox specifies that when a request triggers this violation, BIG-IP Advanced WAF creates a learning suggestion, or increases a suggestion's learning score. The Alarm checkbox specifies that if an illegal request triggers this violation, BIG-IP Advanced WAF records the request in the event log as an illegal request. The Block checkbox specifies that if this violation occurs, BIG-IP Advanced WAF will record the request in the event log as a blocked request. It will also block the request, and it will return the blocking response page to the user. We'll expand the Attack Signatures section. Notice that the policy builder includes a set of generic detection signatures for negative security. Next, we'll expand the File Types section. We use this section to configure file type enforcement. Notice that all file type violations already have the Learn, Alarm, and Block checkboxes selected. This is because we used the comprehensive policy template when we created the policy. This option specifies under which circumstances the policy builder adds explicit file types to the security policy. The Always option specifies we want to create a comprehensive whitelist that includes all the web application file types. The Parameters section is also already configured, because we used the comprehensive policy template type. We'll change this option to Always. And then we'll also change the parameter level option to URL. Using parameters at the URL level enables more granular security than using parameters at the global level. We'll select this option which enables the policy builder to learn qualities of integer or numeric parameters. This checkbox ensures that the policy builder will configure parameter attributes based on the data submit from user requests. And the same is true for the settings in the URL section. Once again, we'll change this option to always. We'll now save the settings and then apply the policy. When updating a BIG-IP Advanced WAF security policy, you must always click the Apply Policy button. Before leaving this page, let's expand the header section. Notice that the Learning and Blocking Settings page displays a description, examples, and attack types for each violation type. We can also use this icon to navigate us to the specific configuration utility page for managing this item. In this case, the Allowed Methods page. Notice that by default only the head, get, and post methods are allowed. We'll now examine a page that is very useful during the policy building process. The Audit Log page. This page displays all the changes made to a security policy, either by an administrator or the policy builder. You can see all the actions taken to update the security policy, followed by the policy being applied. Note that all the current updates were made by the admin user. We'll now create, and then view, some learning suggestions. We'll access the DVWA web application and then close the page without logging in. It's important to note that the Windows workstation has an IP address of 10.1.10.199, which makes it a trusted source for building the security policy. We'll reload the Audit Log page. The one web page request generated several new log entries, including adding URLs, file types, and parameters. Note that all the new updates were made by the policy builder. Let's examine the description of this log entry. The audit log provides additional details on the updates made by users or by the policy builder. Let's open the Allowed File Types page in a new tab. From the one request, the policy builder has already added a few file types to the allowed file types list. Notice that they all have 4 different length values. Also notice that they are all in staging. While they are in staging, the policy builder will evaluate each incoming request and may update each file type's length values. Let's now open the Allowed URLs page. From the one user request, the policy builder added the / the login.css, and the login.php URLs to the allowed URLs list. On the parameters list page, you can see that the 3 parameters, or user input fields, that are on the login page, have been added as allowed parameters. Again, notice that these parameters are still in staging. Also notice that they all have a parameter value type of ignore value. This means that BIG-IP Advanced WAF will not yet block requests based on the values submit into these parameters. Also notice that they are configured as URL level parameters, meaning these 3 parameters are only allowed on the login.php page. We're now going to use an Imacro in Firefox. This Imacro simulates several requests to the DVWA web application. Once again, we'll reload the audit log page. The policy builder made several additions and updates to the security policy. There are now several additional file types added to the whitelist. There are now several URLs added to the security policy. They are all still in staging, and many have learning suggestions available. The list of parameters has also grown. All parameters are at the URL level, are still in staging, and some have learning suggestions available. We'll now open the traffic learning page. And then examine the enforcement readiness summary section. This section displays a summary of file types, URLs, parameters, and other entities that have been added to the security policy, that aren't enforced, that have suggestions, and that are ready to be enforced. Notice that there are 4 parameters that are not enforced, but have learning suggestions. We can click this, which navigates us to the parameters list page, displaying only the parameters with suggestions. For the page parameter, we'll click the Learning Suggestions Available icon. This navigates us back to the traffic learning page, with this suggestion selected. Notice the action for this suggestion is to set the parameter value type to user input value, and to set the data type to alphanumeric. We'll select to accept this suggestion, and then use the parameters list page to view the updated settings of the page parameter. The parameter value type is now user input value, and the data type is now alphanumeric. Next, we'll open the Security Policy Properties page, and then scroll down to view the server technologies. These are the web server technology properties of the back-end web application, which were discovered by the policy builder. On the Learning and Blocking Settings page, we'll examine the Attack Signatures section again. BIG-IP Advanced WAF updated the security policy by adding additional signature sets for the server technologies it discovered. This increases the negative security for this security policy. At the bottom of the page, we'll examine the Advanced Options, and we'll then view the Policy Building Process section. This section displays advanced configuration options regarding how the policy builder builds the security policy. We'll expand Trusted IP addresses. The network address we entered when we created the policy is a trusted IP address range for building this security policy. Trusted sources build a security policy more aggressively than untrusted sources. The loosened policy options specify the number of sessions, the number of different IP addresses, and the amount of time that must pass for the policy builder to identify a new security policy suggestion, or increase a suggestion's learning score, based on user requests. Notice that there are separate values for untrusted traffic and trusted traffic. We'll lower 2 of these values to speed up the learning process. We'll then expand the Tighten Policy Stabilize section. These values control the number of requests and the amount of time that must pass before the policy builder will stabilize a security policy setting. We'll modify all 3 of these values. Finally, we'll expand the Minimize False Positives, Track Site Changes section. These values control the number of requests and the amount of time that must pass before the policy builder will destabilize a security policy setting based on updates to the web application. We'll first select only from trusted traffic and then lower this last value. In case you're curious, 0.001 days is the equivalent of about 90 seconds. By modifying these values, we'll simulate policy building at a much more rapid rate. It's important to note that these settings will only affect requests coming from trusted sources. We'll now save and apply the policy. Using a new private window, we'll now run a second Imacro to simulate more user requests. We'll reload the audit log. The policy builder made thousands of additions and updates to the security policy. On the Allowed File Types page, notice a couple things. The wildcard entry is no longer on the list. This means that BIG-IP Advanced WAF considers this list complete. However, it's still open to learning new file types to add to the list. Also, the file types are no longer in staging, which means BIG-IP Advanced WAF will enforce the length limit values. On the Parameters List page, the list of parameters has grown considerably. Most parameters are still in staging. And most parameters also now have a parameter value type of user input value. Let's examine another new page, the Tree View page. This page displays all the allowed URLs and parameters for this web application in a hierarchical format. Also, when we select an item, such as this username parameter, we're redirected to the Parameter Properties page for the username parameter. Next, we'll begin the process of stabilizing the security policy. While entities, such as file types, URLs, and parameters, are still in staging and not yet enforced, the security policy is not yet stabilized. On the Learning and Blocking Settings page, we'll adjust the learning and staging speeds again. By lowering the time values, we're drastically decreasing the time required for the stabilization process. This new time value we're entering equals about 18 seconds. Again, as a reminder, these lower values only affect requests from trusted sources. We'll now use a new private window and rerun the Imacro. Remember, these requests are all coming from a trusted IP address. On the Audit Log page, We can use this option to filter the log entries and view only updates to the security policy. We can then use this option. And we are now viewing all updates, but just for parameters. We can also filter the log entries to see every time the policy was applied, either by an administrator or the policy builder. Once again, we'll rerun the Imacro. We can also use the audit log to view all the individual updates the policy builder made to a specific element. In this case, the MTX message parameter. We can see updates to the parameter value type, the maximum length, and overridden meta characters. We can also see all the additions, updates, and deletions made by the policy builder or a specific BIG-IP administrator. We'll rerun the Imacro again. Remember, as long as 18 seconds have passed, and we're using a new session with a private window, these trusted requests will help to quickly stabilize the security policy. We'll now examine the Display Preferences page. This page enables us to have BIG-IP Advanced WAF suggest action items to signal administrators of specific actions, or action items that should be completed. Notice that all the suggested action item types are currently enabled. Next, we'll examine the Application Action Items page. We use this page to view suggested action items, quickly link to common configuration screens, and to view the progress of the policy builder. The Policies Summary page enables us to view how many security policies and entities are in automatic, manual, or disabled mode. View a list of active security policies and the number of action items for each security policy. Let's select our specific security policy. If there were any action items for this security policy, they'd be listed here. There are also links to useful configuration pages and reports. For example, these are all the current learning suggestions for DVWA security policy. In automatic mode, once the learning score for a suggestion reaches 100%, it will automatically be added to the security policy. Therefore, there are no suggestions on the page. We'll use the filter option and select to view all suggestions that have been accepted and staged. We'll narrow down the filter by only viewing suggestions for the MTX message parameter. These are all the learning suggestions that have been accepted into the security policy for this parameter. Notice that all suggestions have a learning score of 100%. When using a trusted source, it takes only one request to give a suggestion a learning score of 100%, And when using automatic policy building, these suggestions are automatically accepted into the security policy. For the last time, we'll rerun the Imacro. We'll then examine the Audit Reports page. This page provides very specific reports about flows, parameters, and URLs. For example, we'll run the user input parameters defined as numeric, integer or decimal report. Two parameters have been classified as integer parameters. Let's run the user input parameters with at least one allowed meta character report. 3 parameters have at least one allowed meta character. Finally, we'll run the user input parameters with overridden attack signatures report. There is one parameter that has at least one overridden attack signature on the vulnerabilities/xsss URL. We'll select the vulnerabilities/xsss URL, which navigates us to the HTTP URL properties page for this URL. The URL parameters page displays the 3 parameters used on this URL. They are no longer in staging, which means they are all enforced by BIG-IP Advanced WAF. On the parameters list page, you can see that almost all parameters are no longer in staging and are now enforced. We can also select an entity, such as these 2 parameters, and manually enforce them. The list of parameters is now stabilized. For the MTX message parameter, we'll open the Attack Signatures tab. We can quickly see which attack signature was added to the overridden settings for this parameter. We've decided to not allow this attack signature for this parameter. On the Allowed File Types page, notice that the query string length for the no-ext file type was changed to 2048. This was due to user requests that exceeded the default 1000 length limit. All file types are no longer in staging and are now enforced. The list of file types is now stabilized. Now that the security policy is stabilized, we'll open the Security Policy Properties page and change the learning mode to manual. In manual mode, updates based on learning suggestions are no longer automatically added to the security policy. For the next part of this demo, we are going to use a utility called Burp Suite, which enables users to intercept requests before they leave their workstations and go to the server. Note that by default, the intercept feature is turned on. For now, we'll turn this off. In order to use Burp Suite, we need to adjust the proxy settings in Firefox. We'll now log into the DVWA web application as a malicious user. In Burp Suite, we'll turn the intercept feature back on and then select the Setup page. We can now view and modify the request in Burp Suite before sending it to the web server. For example, we'll modify the HTTP method from GET to DELETE. Clicking forward sends this request to the web server. This malicious request is blocked by the BIG-IP Advanced WAF security policy. Let's try another malicious request, this time using the command execution page. We are going to attempt to add another HTTP header, which includes an attack script. This request is also blocked by BIG-IP Advanced WAF. Next, we'll try an attack against the About page. We'll attempt to add several extremely long, fake, HTTP headers with the goal to overwhelm the web server. This malicious request is blocked by Advanced WAF as well. We'll now attempt some additional malicious requests using several parameters. We'll start by submitting a user's first name into this field. Because we're attempting to submit a text value into an integer parameter, the request is blocked. Next, we'll submit the number 2000 into this field. Because we're attempting to submit a numeric value that is too high for the ID parameter, the request is blocked. We'll now submit a text string with several keyboard characters into this field. Because we're attempting to submit keyboard characters that aren't allowed for this parameter, the request is blocked. Next, we'll submit a review that contains a malicious script in this large field. Because we're attempting to submit a cross-site script attack into this parameter, the request is blocked. Finally, we'll submit a review that includes the script we previously removed from the overridden attack scripts for the MTX message parameter. Because we're attempting to submit a text string that matches a BIG-IP Advanced WAF attack signature, the request is blocked. Let's examine these blocked requests using the BIG-IP Advanced WAF event log. First, we'll filter the log file to show only blocked log entries. This request was blocked because the user submitted the request with the delete method, which is not an allowed method. Notice the malicious content is highlighted in the HTTP request. This request was blocked due to 6 detected attack signatures. BIG-IP Advanced WAF checks for attack signatures anywhere within the HTTP request, including the HTTP headers. This request was blocked because the HTTP request length was too long. The maximum length allowed for the PHP file type is 5000 characters, and this request was for 5286 characters. This request was blocked because the ID parameter is configured as an integer, and we submitted the text string of Bob. This request was blocked because the ID parameter is configured for a maximum value of 50, and we submitted a request with a value of 2000. This request was blocked because there were 4 meta characters that were submit into the name parameter that aren't on its allowed meta characters list. This request was blocked because it matched 9 attack signatures. And finally, this request was blocked because it contained the attack signature string that we removed from the overridden attack signature list for the MTX message parameter. In the last part of this demo, we'll update the security policy due to false positives. A false positive is a valid request that is blocked by BIG-IP Advanced WAF. For example, the numeric value limit for the ID parameter that blocked the request was a false positive. While viewing the event log entry, we can click this link, which opens the traffic learning page in a new tab with the suggestion selected. Notice that the suggested action is set maximum value to 16,384. We'll accept this suggestion and then return to the event log. The 4 meta characters that were blocked should actually be allowed for the name parameter. This was another false positive. On the traffic learning page, we'll select all 4 suggestions. Notice the action is to allow each meta character for the name parameter. We'll accept all 4 suggestions and then apply the policy. Let's try to submit these 2 requests again. We'll first attempt to enter the value of 2000. The request is now allowed. Let's try to enter the value of 20,000. This request is blocked, as it violates the maximum value of 16,384. We'll now try to submit the request with the multiple keyboard characters. The request is now allowed. Let's submit another request, this one including the pipe character. This request is blocked because the pipe keyboard character is not on the allowed meta characters list for the name parameter. Let's open the SQL injection page. And then at the bottom we'll select to open the View Help page. The request is blocked, however users should be able to access this page. Right now, it's triggering another false positive. We'll reload the event log and then select the newest log entry. This request was blocked because it's an illegal URL, and it contains 2 illegal parameters. We'll click the link for the illegal parameter violation. Then select both parameters. And then accept both suggestions. On the Allowed URLs page, notice that the vulnerabilities /viewhelp.php URL has been added to the list. The policy builder added this URL when we added the URL level parameters to the security policy. We'll apply the policy and then attempt to access the page again. Users can now access this web page. Thank you for watching this exercise on using F5 BIG-IP Advanced WAF to stabilize security policies. We encourage you to watch additional AWAF demos and exercises, and for more details on how Advanced WAF can protect your web applications, contact your F5 Network Sales Account Manager. For questions or comments about this video, contact Chris Manley at the email address at the bottom of the page.